Hi everyone. During my previous videos we have seen smoothing and we have used averages in order to smooth the time series. We have used as well exponential smoothing during my previous lecture. Now we are going to cover more advanced topics in smoothing. So let's go to my full desktop. So I have put this picture here for advanced exponential smoothing. This is just to say that we have very different ways in order to perform smoothing in our time series, in our data sets. Yes, so here we have the 007 agents that obviously they act as a type of smoothing. I am a fan of this series. I was wondering if what is your favorite 007 agent? All right, so we are going to cover the Holts method here. Yes, and with the idea of the 007 agents, I would like to explain a little bit the Holts method or double exponential method. The idea is to augment the simple exponential smoothing by capturing a trend component. That is the main idea of this session today. So in general, we are going to have this term here, which you know that is F means forecast. Yes, T means time or the actual time that you're analyzing, and K is the number of periods of time that you are going to forecast. Yes, ahead. So let's type time ahead. Yes. So apart from this ft plus k, we have as well L. Yes. I think you already know that L is the level. Yes. Or the average of the whole data set. T remains being time plus K. This is a constant. Yes. A constant. And T is the trend in time t. So as you can see, we have time t, and time f t plus k. This k can be 1 if we are forecasting the immediately next period of time. Yes, the next observation in time. Right? So that is what it means. So let's imagine that we are analyzing the killings of the agent 007 per year. Yes, you know that more or less every 2 or 3 years we have one series of this 007 agent. Yes, so let's put here 1990. Yes, we have 50 killings of people. Yes, 000 killings, right? And in 1995, to say something, we got 60, right? And in 2000, we have 35, just 35. In 2005, we have a lot. Let's say we have 75. Well, although sometimes in the reality, I am just inventing these figures, but in the reality, you know that sometimes they kill the whole cities or whole populations. You know, I think the most recent the movies, I think we start killing the world and other planets as well and other cultures. Anyway, so the next in 2010 says that it was 65, 2015 let's say that it was 80, and 2020, let's say that the next movie of 007 is going to kill, I don't know, 100. Yes, So with these guys, we are able to find this trend, yes, because we can estimate the trend, or we did estimate the trend with a moving average. Moving average. Yes, so if we do this, for instance, let's say that the moving average has a window equal to 3. So we'll take first this 3 and make an average of these 3. But this will be the average of these 3, more or less, that is 145 divided 3. It will be something like 145 divided by 3 for 248.9. Yes, so we can write here 48.9, and then we can take the next 3 averages, which is going to be 95 plus 75 is 170 divided 3 is going to be like 5, something like this. Yes, 56.6. And we can carry on calculating the moving average, as you can see. And then we will be able to calculate this trend by means of calculating these moving averages, as you can see from this example of the 007 agents, the killings that we see on these movies, right? So as you can see, this is the equation that we do. So we use the average, right, of the whole data, and then we update that average with the latest, with the same period or the previous period from this forecast moving average. Yeah, in doing that, we are all the time updating the level, yes, and by means of these constants, we are going to give like a power to this trend, to this trend component. Okay, I wouldn't like to go like very like into the details, but we said last time that alpha is the learning component. So if alpha is here equal to 0.3, what I am saying is that this level is going to learn 0.3 or 30% from the previous observation of YT. Say that this YT is GDP, or any variable that you are trying to calculate, to estimate. Yes, plus 1 minus alpha. 1 minus alpha will be equal to, in this example, 0.7. So we will be saying here that this level is learning 70% from the previous level, yes, in the previous period, plus the trend in the previous period, right? So in general, what we are doing is that we are adjusting the previous level by adding a trend. Yes, so we did this, we did like all of this during my previous lecture. All that we are doing is to adjust the forecast or the level by this, by adding this trend. And I set this example here of surfing, because when you want to surf, I think you need to look for the level. Recall that the level is the average of your data, this average, yes, but you also need to see for the trend. So if the wave is going in certain direction, yes, let's say that the wave is going in that direction, so you need to surf in the right place, so you will see how the wave comes, you see the level, and then you try to catch the trend, and if you do the things right, so then you will surf. And that is something that we are actually doing here in forecasting. Yes, we are analyzing the level and the trend of our data, yes, to capture the waves the most, like in the best way we can. So this is the question 2, estimating the trend. So we already estimated in the previous equation the level, which is obviously one of the things that we want to estimate here. Remember, level and trend. So first of all, we estimated the level. Second of all, we are going to estimate that trend. Yes. So we are going to update the trend by a beta factor. Yes. So this is another learning component, but different from the previous one, because this beta is going to learn from the level and this trend. Yes. Again, we are learning here for the difference between the actual level and the previous level. Yes, the previous observation level, the previous time level. And we are also learning from the previous trend. This trend learns from the previous trend. In the same manner that before, if this is 0.3, we will be learning 30% from this difference and 70% from this trend. So this is equivalent to 70%, right? 70% from the previous trend. In doing that, we are trying to estimate the trend in the actual period. Yes, today. This T means that is the actual period T. So in a nutshell, we are updating previous trend using the difference between the most recent level values and a local trend. The trend is allowed to vary adaptively over time. Yes, compared to regression-based models. Again, what we are trying to do is to get the right trend and the get level here, yes? So in this example, we can catch the waves the best we can and surf, right? I like a lot this example or this metaphor that I have in there. Okay, so how to choose alpha and beta? So we have default values as we did before. So default values for beta and alpha are usually 0.2. So by means of iteration, yes, this is trial and error. An algorithm tries to find the best combination of these two. Yes, and by means of that iteration, then we will be able to find a solution. A solution for the model, right? One, in order to find this solution for the model, then we need to minimize the root mean square error. This root mean square errors, if you remember my session of performance and evaluation, is the way to compare like two forecasts or two regressions. Yes, what in general what you do is to compare the errors, and the closer the errors to zero, then you choose that a regression. So by means of iteration and comparing the root mean square errors, or comparing any other type of indicator, yes, to evaluate the errors. This is, for instance, a different measure of goodness of fit criterion, yes. This is the mean or the moving average, moving average percentual error. Yes, so by means of that, we can as well try to find what is the best solution by comparing what of the solutions is closer to zero. There is as well another criterion, which is the Akaike Criterion. Uh, we are not going to cover this here, but in general, this Akaike Criterion tell us at what extent we are overfitting our like setup, our model, yes. So the danger of overfitting is that sometimes if we run a regression with different data, we are not going to get the same results, yes. So the Akaike criterion, what it does is to try to let us know if we are uh, having the danger of overfitting. So what to do if there is a danger of overfitting? Make sure chosen values are reasonable, yes? And if those chosen values for alpha and beta are reasonable, I think you can conclude that it is going to be a good model in order to forecast. Okay, guys, so keep calm. I am a fast learner, so this is very interesting because here we are not just using alpha to learn, we are using alpha and beta to learn. So as you can see, we are now very well much into analytics. We are setting we are setting the computer, we are setting an algorithm that learns. Alright guys, this is my first video. I will carry on covering a short example now, so I hope you see my next short video clip.